Okay, welcome OChem 8C students. So today we're going to go over the week 10 worksheet 1 worksheet. So if you guys could all please just sign into the description box and we can get started. So for this first question, I did it a little bit different this time where I just write out the answers and I explain it. That way I have time to do that. So for the NaBH4, this is a reduction. You guys have seen it many times, but now we're just working with sugar chemistry. So when you have NaBH4, what it does is it reduces this aldehyde on carbon 1 into a CH2OH. So we have aldehyde forming CH2OH, which is this one right here. And that's it. Nothing else gets touched. So for this next one, the Br2H2O, this is an oxidation. And so is the HNO3. They're both oxidation, but which makes each one unique is the fact that for the Br2 oxidation, we only oxidize the aldehyde. So this carbon 1 is an aldehyde, and we see that when we react it with the reagent, Br2H2O, we form a carboxylic acid only on carbon number 1. Whereas for HNO3, we form carboxylic acids on both ends. So we have it on carbon 1 and also on carbon 6. So we have on this one, aldehyde turns into carb acid. And for this one, we have aldehyde plus end of sugar form a carb acid. Okay, so now let's move on to number 2. So for number 2, we're looking for the reagent that'll give us an OH on carbon 1, whereas everything else is an OMe. So there are 2 reactions that will give us different esters, right? So we have glycoside formation, so I'll write this out. So we have glycoside formation. And a reagent that you'll see for glycoside formation is something like CH3OH and an acid. So we'll add this CH3O part. So if we did a glycoside formation on this reactant, we would get that only the anomeric, which is this one right here, forms an OMe. Versus when we use the methylation reaction, which involves this Ag2O with CH3I, that'll actually form all carbons become OMe. So we'll most likely use that first reagent since we want to turn all of our carbons, with the exception of the anomeric, of course, into OMe. However, we see that in our final product we have an OH. So first thing we're going to do, there's an intermediate step where everything is an OMe. But then when we react water and an acid, like H2O and H2PO4, what that does is it converts the anomeric carbon into from an OMe into an OH. Okay, so for the last one, this is a Kiliani fischer, and what it does is it's a chain reaction. So it'll elongate the chain by 1 carbon. And so we have the reactant right here, and what happens is that we're gonna add an additional carbon. So I drew that in red, and it'll be on the second carbon, and we have both the enantiomers of that because it could either be on both sides. So that's it. That's all we have for today's worksheet. And if you guys haven't signed in yet, please sign in into the description box.